Hi, so today we'll be going through powers and indices. Powers and indices. So, what are powers and indices? So, first of all, we know what, um, do you know what 2 times 2 is? Right, it's 4. And what is 2 times 2 times 2? That is 2 times 2, which is 4, times by 2, which is 8, right? Now, you can keep doing this. You can have multiple multiplications, right? 2 times 2 times 2 times 2. But this can get rather tedious, right? Because if we keep making it bigger and bigger, bigger, because you can see the equation gets longer, longer, and longer. And that's something that is we don't want necessarily. So anyways, this is 16. But we want to find a shorter way of denoting this. Now, this is where powers and indices come in, right? So we can actually write this as 2 to the power of 2 or 2 squared. It's the same thing. We can also have this as 2 to the power of 3 or 2 cubed. And we can also have this from 2 to the power of 4. And I hope you're noticing a pattern here. So first, we have the number. So this number is the same as the number that is being multiplied. So 2 times 2 times 2, and so on. And here we have another number which actually represents the number of times the number appears, or the number of times that number has been multiplied. So for instance, we have 1, 2, 2's in the first equation. We have 1, 2, 3 2's in the second equation, and 4, 3, 4 in the fourth, right? The fourth calculation. So as you can see, that denotes the number 4, and for the previous one, number 3. So it's very helpful for us to very much shorten this. Now, this works for every number essentially. So not so you can have, let's say, you can have 3 squared, right? Which is the same as 3 times by 3, which is equal to 9. So it's not restricted to 2. It's just for example. Now, another interesting property of this is that if we were given 2 numbers, let's go back to our 3 example. Let's say we had 3 squared times by 3 squared, right? What would this be? Well, if we were to write this out, this is the exact same thing as saying 3 times 3 times by 3 times 3, which is the same as 3 to the 4, because here we have 1, 2, 3, and 4 threes. So that's very interesting that we have 4, and then we have a 2 there and a 2 there. So that means it's the same as saying 3 to the power 2 times 3 to the power 2 is the same as 3 to the power of 2 plus 2, which is 3 to the power of 4. Right, so that's very interesting. That's very helpful. So if you had, for example, a 2 to the power of 4 times by 2 to the power of 6, what would that be? That'd be 2 to the power of 10, right? 4 plus 6 is 10, so 2 to the power of 10. Amazing. Now let's say we divide it, right? Let's say we had 2 to the power of 6 divided by 2 to the power of 3. What would that be? Well, if we were to write this out, and I think the best way would be to show through a fraction. So let's say we have 2 times 2 times 2 times 2, 1, 2, 3, 4, 2, and another 2. Right, so that's 2 to the 6 at the top. And this is all divided by 2 times by 2 times by 2. Right, so 3 2's. So why are we doing it as a fraction? Because it's a lot easier for me to show what's going on. So usually when you have a fraction, what you can do is that you can cancel out like terms. So we got a 2 here, so we can cancel that out. 2 here, cancel that out. Cancel 1. Cancel this one, cancel this one, cancel that one, cancel that one. And then we are left with 2 times by 2 times by 2, which is the same as 2 to the power 3. And you can notice that 2 to the power of 6 divided by 2 to the power 3 is the same as 2 to the power of 6 minus 3, which is 2 to the power of 3, right? So knowing these facts, we can say that, let's say we had a number a, right, to the power of n times by a to the power of m, n and m is the same as a to the power of n plus m. And if we had a to the power of n not times, divided by a to the power of m, this is the same as a n minus m, right? So this is a very, very simple but important rule to remember. So it's something that you should always practice because it is very important when it comes to working with powers and indices. Now, because of this, there are also 2 other important things to note. Let's say we had a number, let's say 6 to the power of 1. What would that be? Well, considering that the number dictates the number of times the number appears, so it makes sense to say that it's just 6, right? And it would make sense if we had 6 to the power of 4 divided by 6 to the power of 3. We expect 6 to the power of 4 minus 3, it's just 6 to the power of 1. And also showing it as a fraction, sorry, it'll be 6 times 6 times 6 over 6 times by 6 times by 6. And then we cancel out the like terms. Let's do those there. And 3 here. That gives equals to 6, which is equal to 6 to the 1, right? So it shows that they're the same. Now, what if we had a number to the power of 0? So let's say we had 8 to the power of 0. What would that be? Well, it has to be 1. And why does it have to be 1? I can give an example to explain why. So let's say we had 8, just 8 squared times by, 8 divided by 8 squared. So this is the same as 8 times 8 over 8 times 8. Now, if we cancel like terms, we get rid of the 8, get rid of the 8, get rid of this one, get rid of that one. What we are left with is, in fact, just 1. And remember what we showed earlier is that the dividing is the same as taking away. So 8 squared divided by 8 squared is the same as 8 to the power of 2 minus 2. So that means 8 to the power of 0 is equal to 1. So then it's also good to remember a number a to the power of 1 is just a, and a number a to the power of 0 is just 1. So that is some of the basics of powers and indices, and next time we'll go deeper into different types of powers and indices that we can have. Thank you.